what is the true nature of reality? There are two major theories of the universe: quantum mechanics for small things like atoms, and general relativity for big things like planets. These theories only work in their own domain. Physicists wish to have one theory for all scenarios because small particles make up large objects, and the behavior of these small particles determines the behavior of the large objects. String theory may be the answer. String theory says that deep within all matter particles, like quarks and electrons, and force-carrying particles, like photons and gluons, there lies a dancing filament known as a string. Therefore, the string is the smallest part of everything around us. For every unique pattern in which these strings vibrate, a unique particle is produced. This is similar to how string instruments work. The different vibrational patterns of a string produce different notes, giving music its variety. If this idea is correct, it shows unification of all matter and all four fundamental forces: the strong force, the weak force, the electromagnetic force, and gravity, because all matter particles and all force-carrying particles would be made out of the same basic stuff. For this reason, string theory could be a theory of everything. However, there is a problem. For the math of string theory to work, there must be 10 or 11 dimensions rather than the 4 of spacetime which we are used to. So, string theorists propose that there are two kinds of dimension: large ones that we can see, and small, curled up ones that we can't. Here's an analogy. From far away, this wire looks like a one-dimensional line. However, a small creature like this ant is able to walk along both the length dimension and the dimension around the wire. String theorists say that these extra dimensions are curled up in every little bit of space around us in the form of minuscule shapes known as Calabi-Yau manifolds. The geometry of these manifolds controls how strings can vibrate, much like how the curves of a water slide control the flow of water over it. If physicists need the correct variation of the manifolds, they could calculate the possible vibrational patterns and, in turn, calculate physical constants such as the gravitational constant and the mass of the electron. If their calculations matched up with the known values of these constants, it would explain the values and, in turn, explain the very structure of our universe. I want to emphasize that this is not yet a full-fledged scientific theory. The math is consistent, and the theories it seeks to unify are experimentally supported, but there isn't experimental evidence to support string theory itself. However, the possibility that we may, within our lifetimes, find this evidence is what makes string theory so exciting. And what's amazing is that, if this fascinates you, you can even be a part of it.